What if the moon was replaced by a black hole the size of a marble? Imagine stepping outside on a quiet evening, expecting to see the familiar silver glow of the moon, but instead, the sky looks wrong. Not darker, just empty, like a piece of reality has been punched out. Where the moon should be, there's a tiny, perfectly black dot surrounded by a faint distorted halo of starlight. You'd think it's a glitch in your vision. It isn't. A black hole the size of a marble has taken the moon's place. Despite its tiny size, this object still holds the entire mass of the moon. That means its gravity is nearly identical, at first. So the world doesn't instantly collapse into chaos. For the first few minutes, everything seems strangely normal. The tides barely change. The stars still move. Humanity collectively shrugs and says, "Weird, but okay." But then astronomers begin to scream. Their instruments detect radiation, tiny but unmistakable, coming from the new moon. That's the black hole slowly feeding on particles drifting through space, dust, solar wind, photons. By human standards, it's eating nothing. But by physics standards, it's glowing. And anything that glows in space for the wrong reason is bad news. For hours, Earth remains stable, but subtle changes ripple outward. The tides grow slightly stronger, just a few centimeters, but that's enough to disrupt ocean circulation. Weather patterns begin to shift. Storms form earlier than expected, and in places they never belonged. Meteorologists desperately run new models, discovering that even a tiny alteration in lunar gravity has butterfly effect consequences for global climate systems. Meanwhile, space agencies notice something worse. The moon used to drift slowly outward each year because of tidal forces. But a marble-sized black hole has essentially no surface area. Earth can't push on it the way it pushed on the moon. There's no tidal locking, no stabilizing interaction. Nothing to hold the orbit steady. So the orbit begins to decay. Slowly at first, millimeters per day. Then centimeters. Then meters. Weeks later, telescopes observe the black hole creeping closer, tightening its path around Earth. Scientists frantically calculate impact scenarios, and none of them involve survival. The public panics. Governments pretend not to panic, then panic anyway. As the black hole draws near, Earth experiences the worst natural disasters in its history. Tidal waves hundreds of meters tall carve coastlines apart. Continents shake with global earthquakes as the crust strains against increasing gravitational stress. Volcanoes erupt in chains. Storms reach impossible intensities. The atmosphere itself becomes distorted, pulled unevenly as the black hole's influence grows. Then comes the moment scientists feared: the black hole crosses Earth's Roche limit. It doesn't crash into the planet. It doesn't explode. Instead, it begins to sink, slowly, silently, toward Earth's center like an invisible needle passing through fabric. The planet buckles. Oceans rise and fall violently. The mantle fractures. Over the next hours and days, Earth collapses inward piece by piece. The black hole consumes the planet from the inside, compressing it, heating it, transforming it into a shrinking sphere of glowing devastation. Eventually, Earth becomes a molten, spiraling mass. And then, nothing but darkness, a tiny black hole drifting where a beautiful world once existed. So if someone ever asks, "Hey, should we replace the moon with a marble-sized black hole?" you can confidently answer, "Only if you want Earth to become a cosmic snack."